Good morning and welcome to another video on calculating exact trig values. Now in previous videos we've looked at calculating the sine, the cosine and the tangent of 30 degrees, 45 degrees and 60 degrees. In this video we're going to finish this off by looking at 0 degrees and 90 degrees. Okay. Now before we do that, let's just write down our Sohcahtoa definition. So Sohcahtoa, and the first one we're going to focus on is the sine of 0 degrees. So the sine of 0 degrees. Now we know that the sine is opposite over hypotenuse. Okay. Now we can't really draw a 0 degree angle, but what we can do is we can draw an angle here. We can construct an angle that's quite small, and we can get smaller and smaller. We can get smaller and smaller values until eventually we get a 0 degree angle here. Okay, so if we're thinking about this angle here, let's first of all label our sides. So we've got our opposite, our hypotenuse and our adjacent. Okay, and I'm also just going to label this one y because we'll need that in a moment. Okay, so the sine is opposite over hypotenuse, so it's this length here, so in red, and I'll just highlight the hypotenuse in green. There. Okay, now what is happening to the opposite? As our angle gets smaller and smaller, notice that our opposite is also getting smaller and smaller. Okay, and as we reach 0 degrees, we lose our opposite, it vanishes. So at 0 degrees, the opposite, the length of the opposite is 0. Okay, now the hypotenuse isn't really changing, that's still the same throughout. So we've still got our hypotenuse, but the key thing to recognize here is 0 divided by anything is always 0. It doesn't matter what the hypotenuse is, 0 divided by anything is 0. So the sine of 0 degrees is 0. Now let's have a look at the cosine of 0 degrees. So we know cosine is adjacent over hypotenuse. Okay, and if we label our adjacent in blue, okay, and I'll just label all of these angles in blue. Okay, now think about what's happening as our angle gets smaller and smaller. Hopefully you can see that what's happening is our hypotenuse, we're squishing down our hypotenuse. Okay, we're squishing down our hypotenuse. So this is our hypotenuse, now it's this line here, and eventually when we hit 0 degrees, our hypotenuse is just on top of our adjacent. So the hypotenuse and the adjacent are actually the same line. Okay, so at 0 degrees, our adjacent, we can just say that our adjacent, or our hypotenuse is the adjacent. It's turned into the adjacent. They're both exactly the same. And you know that whenever we divide one thing by itself, we always get the value of 1. So anything divided by itself is 1. Okay, let's have a look at the tangent of 0 degrees now. So tangent is opposite over adjacent. Okay. And so what's happening as our angle gets smaller and smaller? What's happening to the opposite? Well, just like before in the case of the sine, the opposite is getting smaller and smaller and smaller until we hit 0. Okay, so at 0 degrees, our opposite has length 0. And again, it doesn't matter what our adjacent is, because 0 divided by anything is 0. Okay, now what I'd suggest and highly recommend you do now is have a go at working out the values for 90 degrees yourself. I'm just going to cut this. So pause the video. Okay, I'm assuming you paused the video now. So let's have a look at the sine of 90 degrees first of all. So the sine of 90 degrees. Now sine is opposite over hypotenuse. Okay, and because we're thinking about 90 degrees, now I'm going to use this angle here because that's closer to 90 degrees. And as we go down, our angles are getting closer to 90 degrees, and until we get to this point here. So just like before, we couldn't really construct a 0 degree angle, but we got close to it, and that's exactly the same here. This angle started off at just less than 90, and it's getting closer and closer to 90 as we go down. So it's effectively at 90 degrees here. So let's have a look. So because we're now using this angle, this is no longer the adjacent. Okay, so we can change that now. Now this is the opposite, and this is our adjacent. Okay, so the opposite, as our angle is getting closer and closer to 90 degrees, again, the hypotenuse is getting closer and closer to the opposite until we get to the stage where the hypotenuse is on top of the opposite. So they are both the same line. So we can just say that that is the same as the opposite over the opposite. They're exactly the same. Therefore, we get a value of 1. Okay, let's have a look at the cosine of 90 degrees. So the cosine of 90 degrees is adjacent over hypotenuse. Okay, this time, now our adjacent is the shorter side. Okay, and again, just like before, as our angle gets larger and larger, so we get closer and closer to 90 degrees, our adjacent gets smaller and smaller until we get to the point where it is 0. And again, 0 over anything is 0. Okay, now the final one is the tangent of 90 degrees, and this is a bit trickier. So the tangent of 90 degrees. So tangent is opposite over adjacent. So what's happening here? Well, our opposite is still the same. The opposite is still the same length each time, so we can write that in. However, our adjacent is this length here, and again, this length is getting closer and closer, and at 0 degrees, it becomes 0. So it is the opposite side divided by 0. Now, you might want to think about what something divided by 0 is. If you put that into a calculator, you will get a math error because we cannot divide by 0. It is impossible to divide by 0. So therefore, we would say that the tan of 90 degrees is undefined. It is undefined. We cannot define it. We cannot divide by 0. So the tangent of 90 degrees is undefined. Okay, now we've had a look at all of these different values now. Okay, and you will need to know all of these values. However, I have said before that there is a relationship between the sine and the cosine. So you can do a bit of playing around, and there's a few tricks you can do so that you don't need to memorize every single one. And if we just go down to this table here I've got all of the different values that we've calculated so far. And you might be able to spot a pattern, you might be able to spot some relationships. So let's have a focus on the sine and the cosine. So the sine of 0 degrees is 0, and the cosine of 90 degrees is also 0. Okay. Now if we have a look at 30 degrees, the sine of 30 degrees is a half, and the cosine of 60 degrees is also a half. And you can probably see where this is going. The sine of 45 degrees is root 2 over 2, and the sine of cosine of 45 is also root 2 over 2. And the sine of 60 is root 3 over 2, and the cosine of 30 is also root 3 over 2. And you can again see where this is going. The sine of 90 degrees is 1, and the cosine of 0 degrees is also 1. So as long as you know the sine of these angles, then you can easily deduce what the cosine is based on this relationship. Okay, and in fact that's where the name cosine comes from. The this part here, if I just underline the that just stands for the complement. So that's the complement of sine. So that's a really strong relationship here, and you can use this relationship to work out what these values are. And then we've just got the tan of each of our angles, which again you would need to know all of these values here. Okay, so we've gone through calculating the sine, the cosine and the tangent of each of these angles, and you'll get some questions where you'll need to know these values. They won't be given to you, so you do need to know these values. Okay, so hopefully those few videos that I've shown you will help you along with understanding and learning the value of these trig functions, and I hope you enjoyed that.